Next presentation, we're going to talk about some product that are used directly in the mining industry. My name is Nguyen, and I'm the Business Development Manager over here at RIEGL. If you don't know about RIEGL, we'll explain to you a little bit, but more importantly, I want to explain to you some of the application that can directly implement it into the mining industry. Just a quick overview about RIEGL and some of the use of LiDAR technology. With 10 minutes, I'm not going to be able to go into LiDAR technology and exactly what it does, but if you have heard of LiDAR technology, I think this would be very beneficial for application. And we'll talk about some of the trends that we've been seeing in the mining industry using LiDAR technology. If you don't know about RIEGL, we make some of the most unique LiDAR platforms for all industry, from terrestrial platforms to airborne, mobile, unmanned, and industrial. Here's a little bit more background on RIEGL too as well. RIEGL uses instruments in very harsh conditions. We understand the conditions that the mining industry operates in. Our instruments are IP64 rating machine. They operate in fog, dusty condition, and also rainy condition too as well. Some of the big benefits of using LiDAR technology, as you can see from that little area around here, we have an area that has the background, which is the terrain, but also the top of it is a mesh layer. So LiDAR technology can penetrate such layers and also achieve data from the ground for slope stability monitoring and such application. You can see here. Here, I'll talk about some of the different application and setup for for scanning open pit mining. We can also operate underground too as well. So open pit and underground is the same principle. Since LiDAR technologies are active sensors, LiDAR technology can scan in pitch black conditions and environment. As you can see here, to get full coverage of an open pit system, you can have them set periodically throughout the open pit and then calibrate all those systems together to work as one homogenized systems too as well. Or the other platforms you can also use that we've used for many mine sites, and for safety reasons, you can mount them on top of vehicles for such as stop and go scanning as well. And each system, each position scans at a very fast rate. So just to give you an example, to collect a full 360-degree scans, it only takes less than just approximately 1 minute. And we have different systems for different applications. If you can just excuse me for one moment, I think, okay, no problem. Not only that we use our systems in a traditional surveying methodology, we also can implement them and integrate them on a control machine. As you can see here, this is an example in a very large open pit mine in Germany where we installed a controller system onto a conveyor belt-like system to where this is supposed to be a video that shows you the fill of the materials into a mine pit, and the system is mounted on top of this arm, and the data is then fed directly to the operator to where the machine will rotate accordingly to the measurements on top of the ground. So the machine can then rotate to certain location to fill more dirt and so what. And it also control the amount of dirt that's being put onto the conveyor belt so the machine arm can move accordingly to where it needs to be to get that perfect elevation. And this is a must, because when you excavate the mine, you must put it back to where it needs to be. So by integrating such system into a conveyor belt arm machine, we can then locate the amount of volumetric dirt that we fill and cut from an area in time, and that's when we'll talk about 4D in a little bit. Some of the trends that we've been seeing with LiDAR technology, of course, device connected to remote sensing. And LiDAR technology is a form of remote sensing to where we can put the system online, and we can operate it pretty much anywhere in the world. We can also upload the data directly to a cloud or to a proprietary FTP server to that data management can be accessed from anywhere within the organization and industry. Another systems that we've been seeing a lot in the trend of mining are UAV systems. Now, of course, UAV systems could be used in two methodology, one photogrammetry platform and the other one LiDAR technology platform. I have to say, you have to understand the difference between photogrammetry and LiDAR technology. Photogrammetry, of course, are passive sensors, which interpolates 3D models from oblique and nadir angle photogrammetry. But with 3D laser scanning, we measure in real time and three-dimensional measurement. So we collect X, Y, and Z points in real time, and then the data could be uploaded directly to a cloud or to an internal server. And temporal data collection, that's where we talk about changes in time. So with LiDAR technology, since the processing can be done in real time, we can then think about 4D application such as monitoring, slope stability, and also changes, surface changes in real time. Just a quick overview of a typical LiDAR systems that we have dedicated for the mining industry. Here's are the quick specs. We have this particular system at our booth, so if you want to take a closer look, you can certainly come by my booth and pick my brains on what the system does. But just to give you a quick understanding about one of our LiDAR technology dedicated for the mining industry is the VZ2000i. This system particularly has incredible ranging capability up to 2,500 meters. It has 4G LTE capability too as well, to where the data could be uploaded to a cloud or to an Amazon FTP server or to your internal business server. This thing scans at nearly 2 megahertz, so that's 2 million points per second. And with external GNSS, we can also tie this database down to a localized grid, which are normally, on all mine sites, they have their own localized grid. Storage-wise, can be stored internally, and it's a very nice systems for geodetic survey, volumetric surveys, and also for stop-and-go scanning too as well. Let's get into the hardware and the remote operation. So in the future, I believe that remote sensing should be completely automated. Now, whether it could be operated remotely or data could be stored remotely, and with the RIEGL technology, I think we've implemented that into all of our laser scanning systems. You can see here, systems can be mounted all throughout the mine site. All the data could be uploaded into a localized internet sharing center, Internet of Things kind of sort, and data could be accessed from anywhere in the world. It could be triggered anywhere in the world. Cloud storage. So cloud storage has always been a big thing for us now, and with the capability of the 4G LTE network, which can be used by a SIM card, you pay for the data usage, and then the data could be stored directly to a cloud. Access could be accessed anywhere in the world. Not only that we have terrestrial laser scanner, we also have kinematic system too as well. Here we shows a picture of a drone. Well, it's supposed to be a picture of a drone. Oh, sorry. Well, to the left here, you can see the flight plan and trajectory. All of our systems, LiDAR kinematic systems, are completely unmanned. So you just program the trajectory, and it goes accordingly to the path. The data is then stored on board, then post-processed a little bit later. Of course, this is one of the most safest way to collect data in the field. And at RIEGL, that's what we're really all about. We're all about collecting data efficiently, effectively, and more importantly, on a safe level. From 3D static data to dynamic 4D data. Now, what does that mean? Static data in 3D can collect in real time. But what's more important is that we stamp and provide that data to a location that's centralized for all of our customers to use. Therefore, by implementing a system statically, mounted permanently. The data be collected in interval of whatever time you want it. You can have it scanned every 10 seconds, every 10 days, every 3 months. It doesn't matter. We can program the scanner to scan in different intervals. The data can be analyzed, processed, and uploaded to a cloud or to a database to where management can see the changes and such in real time. This animation is static animation where we have scanners mounted. I think my microphone might have went out or something. Oh, okay. I guess I ran out of time, so. But I was on my last slide anyways, and this is my last slide, so please visit by our booth. I have way more explanations to tell you if you'd like to learn more about it. Thank you.